Hello. Okay. Hope you had a good Thanksgiving. You should see the desktop and hear me by now. Does everything seem okay? There's still a lot of people coming in.
Yeah, it sounds good.
Okay. All right. Okay. So what we're going to do today is start talking about objects and classes. We've been talking about objects pretty often during the semester, but we're going to so what we're really going to start talking about is classes. So we're going to approach classes by first reviewing some ideas about objects, and then we'll see what we mean by what a class is. And that's one of the most important ideas in Java, is what a class is. Okay, so the first two readings were these chapters on 9 and 10, which are short chapters on immutable and mutable objects. Okay, so let's review what we mean by objects. So I'm going to open up the Java visualizer. Okay, and remember, an object is something that stores data. So examples we've seen of objects are, for example, a string. So I can have a string that is HELLO. Okay, so let me make it. Okay, now that's a string. Okay, that's an object. Okay, that's an object that we say is of type string. It's a string object. It holds these letters. That's the data in it. So I could do things like I can call methods on the object. So I can say str, what's your char at 2? Okay, but it's going to give me back an answer. The answer is a char, so I want to store the answer somewhere. So I'll do something like this. Okay, but the important thing is that this is a reference variable to the object. In the visualizer, it shows a picture of that. And I can call methods in the object and ask information about the data that's in the object. So that's the data. That would be this first L. Okay, the character at index 2 is the first L. I can also tell an object to uppercase itself. I can tell this object to uppercase itself. Okay, let's see. I'm sorry. To uppercase. Okay. And if I want to see the answer, I should also store that in a variable. So I'll create another string reference variable. Okay. And then if we visualize this, it's real. Whoops, what did I forget? Oh. What did I do wrong?
You
Oh,
capitalize the C.
pardon me?
I think
Yeah, I forgot. Yeah, I forgot to capitalize the C. Okay. Okay. So first we create a reference. Oh, and actually, this is the wrong picture. Remember, for some reason the Java visualizer wants to show that picture as if strings were primitive variables, but they're not primitive variables. They're actually reference variables. So I have to go under here, options, and show strings the other way. Okay. Okay, there's the string reference variable. There's the string object, and it's actually showing us the data in it, HELLO. There's the reference. Okay. I just asked that object to give me an answer. I asked that object, what's your what's your letter with the index 2? What is your letter with the index 2? Now I'm going to ask that object to do something else. I'm going to ask that object to change its. Now, I'm asking the object to give me back another object that is where all the data is replaced by uppercase characters. Notice that I didn't tell this object to change itself. I told this object to give me back a copy. Now, this is the idea of immutable. Certain kinds of objects in Java never change. Once you've created the object never changes the data that's in it. And string is an example of that, and it's called immutable. It doesn't mutate. So if you tell this string to do something like that you would think would mean change, they could have wrote this to change what was in the object. They could have wrote this to just have the object change itself. But the Java designers decided not to do it that way. They decided that strings should never change themselves. They should be immutable and produce another object. Okay. Now let's compare that to a different kind of object. Let's go back here and the textbook uses an I'm going to import something. Java has built into it an idea of a point. Points are used, actually they represent points on the desktop. Okay, so they actually represent points on a desktop, coordinates of a point on the desktop. Now I can now create a point p reference variable and point it at a point object. Okay, and the object can be, say, 1, 2. Okay. Oh. Okay. Oh, I forgot to use the word new. I want a new point. Notice I didn't have to do that for strings. I could have over here said new string, but I'm not required to. So this is the way you get objects. You say, I want a new, then you say what kind of object you want. Then you say something about what should be in the object. Now, strings don't need this extra piece here, but the point does. Okay, so okay, notice I've got a point object. Now, the visualizer doesn't show us what's inside that point. It doesn't show it to us. So if we want to know what's inside the point, we have to print the point. So I'll print out the point. Okay, see, it tells me that X is 1 and Y is 2. Okay, okay. Now, points are not immutable. You can change what's in a point. Okay, I can do the following. P dot, I think this is the right. No, let's see. No, I should have. Let's see. Now I forget which method you use. Okay. So here we're following along here. See, this is what the picture should look like of a point, but the Java visualizer doesn't show us that there's an X and a Y coordinate. Okay. Now, oh, I'm sorry, I made a mistake. I thought points were I thought the impression of points were mutable. No, they're immutable. You can't change what's in a point. Okay. It's rectangle. Okay, it's rectangles. So what's a rectangle? Okay, Java has a way of describing what rectangles are. That's another example. So point is another one that is immutable. You can't change what's in a point. But I can also import rectangle. Okay. Now the way Java thinks of rectangles is you think of a rectangle sitting in the plane somewhere. So if I draw a picture, I mean, you all know what a rectangle looks like, but the way Java thinks about it is that you have a coordinate plane, so an x-axis and a y-axis. Okay, so think of that as a y-axis, and an x-axis. Okay, and then you have a rectangle. Okay, from the point of view of Java, you describe the rectangle by saying where its upper left-hand corner is. So you give it the coordinate of its upper left-hand corner, which would be those two numbers. Okay, see, if we go back over here to the code, see, a rectangle holds four numbers, x and y. The x and y are the coordinates of the upper left-hand corner. So this would be, oops, this would be the x coordinate of the corner, and this would be the y coordinate of the corner. And then you tell Java how wide it is and how tall it is. Okay, so you would tell it what its width, how wide the rectangle is. So that would be this. You would tell it how wide it is, and you tell it how tall it is. So you'd give it its width and its height. Okay, so that's how Java thinks of a rectangle, where its upper left-hand corner is and how wide it is and how high it is. Okay, so what its width is and what its height is. Okay, all right. So you give it these four numbers, but the thing is, a rectangle can be moved around. Okay, so you can move a rectangle around, like they say here. See, they gave the rectangle the name box. Okay, and then they can say, let me change what's in the x coordinate of the box. I'll change the x coordinate of the box by moving it by 50, and I'll change the y coordinate of the box by taking what's in the y coordinate and adding 100 to it. Okay, so let's try that over here. Okay, so I'm going to take a rectangle, and I'll do it the way they did it. Okay, now this put the rectangle at the origin, 0, 0, height, width. Okay, so I'll put the rectangle at the origin, and height was, let's see, they made the height 100 and 200. Okay, so 100 and 200. Okay, and then now the visualizer won't show us what's inside the rectangle. The visualizer doesn't draw this nice picture for rectangles. Okay, they didn't give the visualizer the ability to see inside of point and rectangle objects. Okay, so if I want to see what's inside of it, I have to print it out. The book didn't point that out. In the book here, they didn't point out that if you actually want to see what's inside the object, you have to print it. Okay, so I'll print the object R. You now visualize it. Okay, there's the rectangle object, and we can see that its x is 0, its y is 0, its width is 100, and its height is 200. Okay, now I can mutate this one. Okay, I can do this thing that says, let me change what's inside of it. Okay, so what I'll do is I'll say r.x. Now this is the way, now this is different than what we did over here. Here we call the method in the object. Here we're accessing the data in the object. Okay, so we're switching gears a little bit from calling a method. See, we can see that that's a method because it's got the parentheses to say that there's a parameter there. So on this object, we call this method and give it a parameter, and we get back an answer. Now we're just going to say, follow the arrow of this object. So R is the arrow to an object. Then inside the object, that's what the dot means. It means inside the object. Here it meant inside the object, get the char at method. Here it means inside the object, get the variable x. But we're going to update x to be, I'll just go ahead and update it to say 70. Okay, and then I'll go ahead and print it. And we'll see that we now have mutated the data in the object. Okay. Okay. So created the object, printed it, and we could see that it's 0, 0, 100, 200. Make a change in the object, but we don't see it over here. But if we print it again, we see that the x coordinate changed. We mutated the object. If we were getting nice pictures of the object, we'd see the variables in the object change over here. But the Java visualizer doesn't let us quite see inside of this object. They let us see inside of the string object, but the string object's immutable. You can't go inside the string object and change that data, the HELLO. They can't be changed, but you can go inside of a rectangle object and change one of the pieces of data. And there's 4 pieces of data in a rectangle object, the x, y, width, and height. Okay, so this shows you most of the ideas that we're going to be talking about in objects. Okay, we have a reference variable to an object. We can take the reference variable and point to the object, that's what the dot means, and either call a method in the object or possibly access a piece of data in the object. So here I reach inside the object by following the reference variable, going inside the object to the toUpperCase method. So the toUpperCase method is inside of here. We think of it as being inside that object. And that toUpperCase method can read that data, but it can't change the data. It can read it, and it could build us a new object, this object here, that has the uppercase version of all those. So that method returns a reference, it returns an arrow to the object it built. On the other hand, we can take a reference to an object, look inside the object, and access one of the pieces of data. Now we can't do that. Notice we can't do that in the string case. So one of the things we have to learn is, how does Java stop you from accessing the data in that object? How does Java stop us from accessing that data, but allow us to access this data? Okay, and point, let's see, point, maybe point is mutable. Let's go back to point. I just remember, if we just do p.x equal 70. Let's see if that works. Yeah, oh yeah, that's the way. You just to mutate, points are mutable. You just reach inside the point and change what's in it. Okay, so here's another example. Let's print it before and after we changed it. Okay, so we create a point at 1, 2, then we print it, and then we change where it is from x coordinate being 1 to x coordinate being, I'll just make it 7. Okay. 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 There's our point object. Java the visualizer just shows you the word point. It's a point. We'll see what we mean by instance there, but it's a point. Okay. If we want to know what's inside of it, we can print it. So then the print command can look inside of it and see what's there. Then we can, this thing told Java to go to the point object and change what's in the x variable, and then we can print it and see that x changed. Okay, so point and rectangle are mutable. So this is mutate, okay? And this one here is mutate. Okay? But this one here doesn't mutate. Okay, it's immutable. It doesn't change what's in this object. It takes The data in this object makes a copy of it and gives us back a reference to the copy. Okay. 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 So we're seeing most of the ideas that we want to talk about here. Okay. We have reference variables that are arrows to objects. There's data inside the objects. The data in the object, in some cases, can't be modified. That's what we mean by immutable objects. The data in the objects can sometimes be modified. So point and rectangle, they let you change. Java lets you change the data that's inside them. What we want to do is start seeing the details of things like how do you tell Java that a point is 2 numbers, but a rectangle is 4 numbers? What is the way of telling the Java language, of describing what a point is? How do we decide, or how does somebody decide that a point was an X and a Y coordinate? And for example, it's not a point in 3D space. It's a point in 2D space. So it's only got an X and a Y coordinate. What if we wanted a 3D point? Could we make our own point 3D that had an X, Y, and a Z coordinate? Okay. Same with rectangles. How did a rectangle have 4 numbers in it? Okay, and who chose, and how do you choose that the names are X? How do you choose the names are X, Y, width, and height? Okay, so we want to be able to start talking about how you describe these things to Java. Okay, so far what we're seeing here is how we use them, how we manipulate objects, but we haven't said anything yet about how we would define objects. So we're seeing how to manipulate them, not how to define them. Now, for example, we've learned how to define methods. At first, we learned how to use methods. Really early in the semester, we saw the idea of calling a method with a parameter, but we didn't tell you how to define your own methods. Then later in the semester, we said, okay, now we're going to learn how to define methods. And we spent time writing simple examples of methods. We first learned how to use methods, then we learned how to define methods. And all along, we've been talking about objects, but we've never, excuse me. We've been talking about objects, but we haven't learned how to define our own objects, or how to make objects, or how to define them. We learned how to make them. You make objects by using the word new. Okay, that's making an object, but we haven't learned how to define an object. Okay, so we know how to call a method, and then we did that a lot. We called methods, and then we learned how to define methods. We've learned how to make objects. Now we want to learn how to define objects. Okay, now let me do a couple of things here. Let me make some more point objects. So that's point 1. So that moved point 1, and I'm printing out point 1. Let me create another point, a point 2. Okay, and I'll make that a new point. I'll put it at 100, 200. Okay, and I'll create another point reference variable, but I won't create another point object. This time I'll just use that reference variable. Okay, and then if I want, I can do something like p3 dot y equal -10. Okay, and let me print out all my objects now, all my points. Okay, I have 3 reference variables, but I only created 2 points. Now we've seen examples like this before. One of these reference variables is what we call an alias to another point. Okay, and so when I changed P3, it'll have changed P2 actually. There really isn't a P3. P3 is just another name for P2. Okay, now P1 and P2 are called instances of point. So visualize this, see what I mean. This is referred to as an instance of point. It's one point object holding the numbers 1 and 2. This is another instance of point. It's a point object holding different numbers. It holds the numbers 100 and 200. Now I create an alias to that point object or that point instance. So I have 3 point reference variables, but 2 point instances. Instance is essentially a fancy word for object. We say it's an instance of point, or it's a point instance or point object. So up here they use the word. Notice how people use words in funny ways. Here they use the word object. Here they use the word instance. They're synonyms for each other. It would probably be a little bit better if they consistently used one word, but people don't work that way. People we have lots of redundant words to mean the same thing. And right here you're seeing the word object and the word instance are pretty much synonyms for each other. So you'll hear people talk all the time about saying, I created an instance of a point, or I created a point object. Okay, so this is if I put it, so here I created a point object, or another way to put that is instance of point. Okay, and down here, again, here I created another point object or an instance of point. Okay, and in the Java visualizer, maybe on purpose, maybe they purposely chose to use multiple words just to kind of force the issue that you got to get used to. Well, objects and instances pretty much mean the exact same thing. Okay, instance of that object. Okay, now, so I've got 2 point objects, 2 instances of point, but I've got 3 point reference variables, okay? And then I mutate P3. Well, when I mutate P3, I'm really saying mutate the object that P3 references. So you really shouldn't say over here that I'm mutating P3, because that's a misleading thing to say to someone. They might think you really mean there's an object, that P3 is a different object than, say, P2. Yeah, it's really better to say I'm mutating the object that P3 is a reference to. Okay, so I mutated the object that P3 is a reference to, and if I print out my objects, I see that here's my 3 points. Notice that the last 2 were the same. P2 and P3 were the same because when I updated P3, I was also mutating P2. Okay. Oh, I can make the output look a little bit better by doing this. Put a little bit of information in front of that. Make it a little bit easier to read the output. Okay. Now, in a way, this is a little bit misleading because when it says P2 equals this, it's really saying that the object that P2 references equals this. I mean, if you wanted to, you could say, you could really, instead of saying equal here, you could actually say the object that P1 references equals that. Okay, notice the difference between writing P2 equals this, which is a little bit misleading. But see, most people don't want to write this verbose phrase in their code. They don't want to write the object that P1 references equals that. The object that P2 references equal that. Yeah. Now, okay, so the object that P1 references holds 7 and 2. The object that P2 references holds 100 and -10, and the object that P3 references holds 100 and -10 because P2 and P3 actually reference the same object. We know from the picture here that P2 and P3 actually reference the same object. Okay, so people shorthand say things like P2 is this, or P3 is this, but you have to be a little bit careful. If you write it the correct way, if you really do write it out this really long, verbose way, then actually what you're printing is very accurate. Notice that when you write it this way, you're not saying that P2 is its own object and P3 is its own object. You're saying the object that P2 references is something and the object that P3 references is something. And for all, it's not making a claim that these are distinct objects. The way it was before, it kind of made it look like you're thinking that P2 is an object and P3 is a different object. Okay. Now, programmers learn to think this way while they programmers learn to think that way while they write the shorthand way. We almost always will write the shorthand way. Okay, the shorthand way is a heck of a lot easier to read, but it's a little bit misleading. It seems to say that there are three objects, P1, P2, P3. Okay, this doesn't say that there's two or three objects. It just says the object that P1 references is equal to this. The object that P2 references is equal to this, and the object that P3 references is equal to this. And it's being more precise because it's saying that the object that these things references, it's printing out what they reference. It's printing out what this thing points at. It prints out what this points at. And then this makes it look like you really have three objects when you actually only have two. We're going to keep coming back to this idea. It's such an important idea. And we've talked about it many times before. And you have to keep remembering that aliases can cause confusion. You just because you created a reference variable doesn't mean you created an actual object. Okay, we could do the same thing with rectangles. We could create multiple instances of the rectangle. So this will be rectangle 1. Okay, so that's rectangle 1. Okay, and if I wanted to, I could create a rectangle 2, another instance of rectangle. I could move it somewhere else. It could be at 10, 10. It could have, okay, 10, 10, 10, 20. So it's at 10, 10, and it's 10 units wide and 20 units high. Okay, and then I could print it out. Okay, so now I have two instances. Okay, I have a should capitalize. Point is a what we call a class. We're going to talk about. So we have a point object. So that should be capitalized. Here I have a rectangle object or an instance of rectangle, and here I have another rectangle object. So I have more than one instance of rectangle. Okay, so I have two instances of rectangle, or I have two rectangle objects. I have this rectangle object and I have this rectangle object. And I have two reference variables. Okay. Now, let me show you one last thing before we go on to something else. What if I do the following? Okay. Okay. Here I'm, oh, and then what would be the word for what I'm doing here? I'm taking R1 and I'm doing what to it? What do we call it when we go into an object and change one of the values in the object? Pardon me?
Are you mutating it?
Yeah, that's mute. So I'm mutating R1. I'm mutating the object referenced by R1. Okay? Okay, I'm mutating the object referenced by R1. The shorthand is saying I'm mutating R1. The shorthand way of saying that is mutate R1. But the long way of saying it is I'm mutating the object referred to by R1. I'm mutating the object referenced by R1. Mutate R1. Okay, again, here I'm mutating R1. Okay. Now this one's a little bit tricky. Am I mutating R2?
No.
Why not?
You're creating a new object.
Yeah, so am I changing the object am I changing the object that's currently called R2? That's a little bit hard to answer. Am I mutating R2? Somebody would argue and say you are, and some people would argue that you're not. Okay, let's try to draw a picture of this. Let me draw another picture over here. Let me draw a picture over here to try to explain what we're doing. Okay, so I've got a reference variable that's a rectangle reference variable, and it's got the name R2. And then over here, there's a rectangle object. Whoops, I didn't draw an object. Over here is a rectangle object. Okay, so this is an object of type rectangle. And inside that rectangle object, there's a variable X, a variable Y, a variable height, I'll just abbreviate H, and a variable width. And each one of those variables is a little, they're primitive variables. They each hold a little number. So there's a primitive variable there. There's a primitive variable there. There's a primitive variable there. And there's a primitive variable there. Okay? And this reference variable points at the object. Okay? And if I fill in the boxes, my code here, the reference variable for R2 was 10, 20, 10, 10, 10, 10, 20. Okay, so it had in it 10, 10, 10, 10, 20. Okay. Okay, so that's the picture of this one. Now, what about R1? R1 is a similar picture. I have another rectangle reference variable called R1, and I have another rectangle object. Okay, this reference variable points at that object, and this object What did we put in that one? R1 was 0, 0, 100, 200. Okay. So this was X is, I'll write it differently this time. I'll say X is 0. Y is 0. This is just another way of drawing the same idea. Here, X is a variable, so we think of it as a box holding that number. Here, I'm just using more like a math notation. X is 0, Y is 0. The width is, I forget, what did we say it was? The width is 100 and 200. The width is 100, and the width is, and the height is 200. Okay. All right. So I'm kind of just using two different ways of illustrating the same idea. This object holds those pieces of data. This is another instance of rectangle. So those are two instances of rectangle. They each have their own X, Y, H, and W, their own X, Y, H, and W. Okay. Now, the real question is, what's the difference between these three lines of code and that line of code? And why is this line of code kind of hard to explain? Okay. So this line of code, what we think of it as doing is going here and saying R1, that's this. Follow the arrow to the X variable, okay, and change it to -50. So what that does is I would go over in here and I would erase the 0 and put in 50. Okay, so that's mutating. See, I'm mutating this object. Okay, I'm replacing what value is in there with a new value. Okay, then the next line does something similar. It takes R1, follows the arrow to that Y variable, and replaces it with, so I would erase the value that's in there and replace it with -20. Okay, so I put -20 in there. Okay, this is what the Java visualizer I wish would show us. I wish it would show this nice picture, but for the point in a rectangle, the Java visualizer doesn't give us this nice picture. All right, and then what do? I update one more. I update the height field. So the height is changed to 1000. So the height will be, that value gets erased, and we put 1000 in there. All right, that's mutating. The object gets updated in place. Okay, now we get to this line here. Okay, over my picture, what should I do now? What should I do in my picture for line 36?
I think what it's trying to do is create a new box rectangle.
Yeah, it's creating a new rectangle box, a new rectangle object. So here's a new rectangle object. There's the rectangle object. It's got an X, Y, and a Z. Okay, what are the X, Y? No, I'm sorry. What's the X, Y, W, and H? -10, -10, 50, 50. So there's X equals -10. Y equals -10. Width equals 50. And height equals 50. Okay. All right. Notice that's different than either of the other two rectangles. This rectangle, it's got different numbers in it. It's a different instance. So we have 3 instances of rectangle now. So there's 3 rectangle objects. There's 3 rectangle objects in memory. Now that was this side of the line of code. What about the rest of the line of code? What about that part?
You just have an arrow from R2 going to that new rectangle.
Yeah, so now what I'm going to do is I'm really supposed to erase this arrow here. Okay, I'm going to erase this arrow and redirect it over to here. Okay, now what did I mute? Now, notice I did not mutate an object. When I did this line of code, I didn't mutate an object. I created an object. I did mutate what? What did get updated?
Where R2 is going?
No, what thing in the Java program got changed? Like, okay, go back to this line here. What thing in that picture got changed? What entity, what thing in this picture got changed
The
by
X value of that rectangle object.
right? This variable got changed. Okay, let's see. Oh, I wrote the wrong thing. It was supposed to be -50, wasn't it?
Yeah.
Yeah, I forgot. I should. I can fix that. Oops. That was supposed to have been -50. Let me just fix it real quick. So this was -50. Okay, that line, it updated that variable. It changed what's in that variable. It mutated this object by changing that variable. Then it mutated this object again by changing this variable. Then it mutated this object again by changing this variable. Okay, right? So the object was mutated by mutating the variables in it. Now, this did not mutate any object. It created a new object. It didn't change. No, that object didn't change. This object didn't change, but this object came into existence. So we created a new object. But what did I change? What did get changed? What entity in the picture changed what its value?
I mean, the only thing that changed was the value of R2.
The value of the reference here. This thing changed. This thing changed from an arrow to that object to an arrow to that object. Now, what's the answer to this question?
No.
The answer, that's one. Yeah, the answer is yes and no. Okay, no because of what?
Because it doesn't actually mutate the object that it was originally pointing to.
Right, it did not. Usually the word mutate means you mutated an object. We did not mutate an object. So in the book, when they're talking about mutable objects, see, mutable objects. So usually when they use the word mutate, they mean, did you mutate an object? Okay, this line of code didn't mutate an object, but it did mutate something. What did it mutate?
The reference variable.
The reference variable. And actually, this causes huge amounts of confusion. People mistake the mutation of an object with the mutation of a reference variable. And they write mutate R2. See, you can call this mutate R1, and you can call this mutate R2, but they don't mean the same thing. This mutate R1 really meant mutate the object referenced by R1. And here, if I want, I could say literally, yeah, I mutated R2. I changed what the variable R2 points at. Instead of pointing at that object, it now points at some other object. But I did not mutate an object. Okay, so if I wanted to be really, if I wanted to be really careful about what I'm saying here, this line here mutate the reference variable R2, but not any object. okay? I'm actually mutating the reference variable. Here, I'm actually really mutating the object referenced by. So these really should have been, see, this is really, and this is just a shorthand for that.
A quick question.
Yeah.
Professor. So if the original object of rectangle, let's say if I were to ever want to go back to that now, do I have to just create a new mutation, or can, for whatever reason, if I ever want to just go back?
Okay, that's a real good point, because in Java now, what happens to this rectangle that held the previous values? Oh, first of all, there is no sense in Java of going back. Okay. Java has no notion of saying, can I revert this object back to the way it was? Java has no ability to do that. If you want to revert, you have to keep track. You have to remember somehow. Okay, so the answer is yes and no. Almost everything has an answer that's yes and no. Okay, the answer is no. Java has no way to go back. You can't roll back changes. On the other hand, of course you can go back, but you have to do it yourself. You have to keep track yourself of it. So, okay, now we've mentioned it before. What happens to this object? Does anybody remember the word for this object? What happens to that particular object, that rectangle object? Nobody's using them. Notice that there's no more arrow to that object. So no one's actually using this object. So remember, what do you do with stuff you're not using anymore? What can you do with something that you don't have any use for anymore?
Throws it away.
Throw it away, and that's what Java does. Remember, becomes a garbage object. It is what we call garbage collected, which, to answer your question, means it's gone. So you can't go back to it. It disappears. Okay. Now, on the other hand, here's what I could have done in my code. Let me change my code a little bit. Now watch this. Just before I mutate that object, okay. Oop. Okay. Notice, okay, what does this line of code do? I'm going to back up my picture a little bit.
Oh, it stores the original R2 object.
Okay, say it real carefully. It doesn't store the original R2 object. What does it do? That's real close, but can you say it more precisely?
It references?
Yes, it creates a
reference variable.
An extra reference variable. So in this picture over here, I would do, okay, I'm going to do another reference variable. I'm going to do an R3. There's a third rectangle reference variable. I'm going to point it at the same thing R2 is pointing at. What's that called? Two variables pointing to the same object are called what do you call it when you remember? I'm going to keep going back to these words. It really helps us to use these words. What do we call it when we have two references to the same object?
Instance variables?
No. What do you call it when somebody has a second name? They go by a spy will have a second name. He goes by a what?
Alias?
Alias.
Ah.
Yeah, and that's what we call it. See, P, like this case, I had P3 being an alias for P2. Now R3 is an alias for R2. Okay. Now you get to this line of code here. Now that line of code does what we said a minute ago. It mutates this reference variable to point to this new object. But now can you see the answer to your question? What if you want to go back? What's the answer to the question now if you wanted to go back? So R2's now got this new object. What can I do to go back?
Just reference R3 again.
Or, yeah, one thing, R3, or what if I really wanted R2 to go back?
You can say R2 is assigned R3.
Yes. So that would restore R2 to be pointing to his old object again. That would put R2 back to his old object again. Okay. So R2 starts out pointing at this object. See, can I fit it all on the screen? Need a bigger, wider screen. R2 started out pointing at this object. Then R2 got an alias. Then R2 was made to point to this new object. Now that's mutating R2 in a way, you're changing what R2 points at, but you're not mutating an object. You're just making R2 point to this object. R2 points to this object for a little while, and then this line makes R2 go back to what it was pointing at because we saved it. We saved a reference to this object in R3. So then we can copy that reference back into here and make R2 point back where he was before. Okay, so that's a good point. Like, how do you save something? Okay, now what would be a little bit harder? What about R1? What if I wanted to save what was in R1? Okay, this is R1 is the one that points over here. R1 started out holding 0, 0, 100, 200. Then I mutate R1 to -50, -20, 1000. But now I say, hey, I want to go back. Does anybody see it? Like what could I have done to go back? Did somebody write alias for this?
That was a while ago for the R3.
Oh, okay. I'm sorry. Yeah, okay. So this one's a little bit harder, actually. What if I want R1 to go back? What can I do to make R1 go back? R1 held these numbers here. Then I change it to hold these numbers here. And what if I wanted to go back? Does anybody think, what could I do? It's a little bit actually hard. It's a little bit of work. What could I do to make it go back? The hint is the only way Java can go back to something is it has to be remembered somewhere. What you want to go back to, see, R3 remembered what R2 was. R3 held this reference in it so that we can make R2 go back to the way it was by copying R3 into it. How can I remember what's in R1? What can I use to remember something? In
Just
general,
create a variable that
right,
stores all
so
those.
I could do something like this: int x, int y, int h. So these are my variables I'm going to remember with. What should I put in X? I want to be able to make R1 go back to what it was before. So I need to remember what's in R1. So before changing R1, what should I put in X, Y, and H?
-15, -20, and 1000.
That's not, I can do it better than that.
R1.x.
Right, R1.x. Just copy what's in R1, and then Y will keep track of what?
R1.y.
Yeah, R1.y. And H will keep track of R1.height. Okay, all right. So now I know that they are zero. I know what they are, but here what I'm doing is I'm saying that just use their name. Okay, so X, Y, and H keep track of what was in there. So over here, that would be new instance variables. That would be an instance variable. Oops. That would be an instance variable X, an instance variable Y, and an instance variable H, an instance variable X, an instance variable Y, and instance variable H to keep track of these numbers. Now, how do I make R1 go back? Last thing, how do I make R1 go back to what it was? How can I restore R1 to what it was before I made these changes? Anybody see? Real simple thing now. At this point, real simple little change.
R1.x equals x.
R1.x equals
X.
X. Yeah, because see, we copy it back. See, we had copied it out of R1 into X to hold it. Now we're going to copy it from X back into R1 to remember it. Okay. Okay. So this gives us a sense of how we. These are real good ideas. This gives us a sense of how to work with objects. How do we work with objects?
Would there be a simpler way to do that?
No.
No. Okay.
Yeah. There's really no simpler, better way to do this. You know, if you really wanted to mutate R1, but then go back to where it was, you'd have to store what was in R1 somewhere, mutate R1, do something with it, then make it go back to the way it was. Okay. Similarly, with R2, what we're doing here is we're not mutating any object, we're mutating the reference variable. So if we want the reference variable to go back to what it was pointing at, we store the reference variable temporarily. So here we're storing the reference variable temporarily. Here we're storing the instance variables, the primitive variables temporarily. Okay. Notice that it's a lot of ideas going on here. I mutated this object and I wanted a way to go back to what it was before it was mutated. I didn't mutate this object, I replaced it with this object. And then it's easy to go back to that object just by keeping track of an arrow to that object. So notice it's a lot easier to go from one object back to another object than it is to unmutate an object. Notice one way to, you asked if there was an easier way. The easier way is this way, to replace an object with a new object, then go back to the previous object. Rather than mutate an object, then undo the mutations, that's actually the hard way to do things. It's actually quite often better if you want to change an object to just create a new object, and then you can go back to the previous object, as long as you keep an extra reference to it. Okay?
Yeah, that's what I was asking there, pretty much.
Yeah. So creating a new object to replace an old object is sometimes better than mutating an object. because it's a lot easier to go back to what it was than it is to unmutate an object. To unmutate an object is always hard. You have to keep track of what was there before you mutated it, so you can put back what was there before you mutated it. You have to keep track of all the things that you mutated and then restore them. On the other hand, it's not hard at all to create a new object, use it for a while, then go back to the old object. See, it's real easy to go back to the old object, as long as you kept a reference to it. It's a little bit trickier to unmutate. You know, we don't really have a word for that, but essentially I'm unmutating the object by mutating it again. I have to mutate the object again to unmutate it. I stored what was in the object in extra variables. Then I could take those extra variables and put them back in the object. So I unmutate the object by mutating it again. Yeah. So yeah, there's no such thing as unmutate. To restore the object, I have to mutate it again with the old data. Okay. But so it's actually quite often, it's usually better to think of terms of creating new objects than it is sometimes to mutate old objects. Okay. All right. So Java, now we still haven't said, we're going to start talking about on Wednesday will be how do we actually describe the objects ourselves. So this was again more, we're reviewing working with the objects and remembering the terminology. We want to remember words like instance, object, instance, reference variable, mutate, alias. Okay, we're going to constantly need these words. Okay, now some new words that we have, see the data in the object, those are called fields. Okay, see the rectangle object has 4 fields. They're also called attributes. Okay, so and again, programmers keep coming up with synonyms. They keep coming up with words and words and words. Okay, X, Y, W, and H are called fields. They're called attributes, and they're called instance variables. We have 3 names for them. They're absolutely 100% synonyms for each other. Okay, some people like the word attribute, some people like the word field, and some people like the word instance variable. Okay, so that's what we call these things that are inside. The data in the object is called, usually the word I usually use is instance variables, or yeah, but fields is also used a lot. The word attribute isn't used by Java people very often, but the C# people use it all the time. Okay, so sometimes the word you use depends on what language you're using. For example, Java calls these things are called methods that we call on the object. You know, we call that method on the object. We call that method on the object. Well, C++ programmers call those functions. You call functions on the object. Okay, Java programmers call these things fields. C# programmers call them attributes. Okay, so it's usually more a difference between being a Java programmer and a C# programmer. And so they're called fields or attributes, and they're also called instance variables. They are the pieces of data inside the object. Okay, so what we want to learn to do is how do we describe what a rectangle is? How do we describe that a rectangle has these 4 fields in it? And how do we decide whether those fields can be mutated or not? How do we decide whether or not the fields are like a string, which there's no way to go in there and change that letter? You cannot go into a string and change that letter. Okay, a string object would be a box with the letters HELLO in it, but there's no way to reach in a string object and change one of the individual letters. On the other hand, you can reach inside of a rectangle object and change that field or change that field. Okay, and we did it with this notation here. You can reach inside of the object and change what's in that field. Okay, so I'm mutating the object by changing So if I wrote that out, I mutate the object. I mutate the object by changing the value in a field. I'm going over to the X field and changing the value in that variable. That mutates this object. It also mutates that variable. Okay, so I'm mutating the object by mutating the variable. So if you want, you can say I'm mutating the object by mutating the variable. I mutate the object by mutating the value in a field. In this case, the X field. Okay. Down here, I mutate the object by mutating the X field, the Y field, and the height field. So I mutate the object by mutating 3 fields in it. Okay. And here I remembered what was in those fields so that I could later on remutate the object to get it back to where it was before, if I wanted to. Okay. All right. Now, real quick, what we're going to do is, let me just show you. Here's what it's going to look like. See, this says public class name here. I'm going to define my own rectangle. I'm going to define my own rectangle class. And it's, here's all I have to do. I say that a rectangle has an int x, an int y, an int height, and an int width. Okay. That's my class. That's all I pretty much have to do. Okay. And to show you that I can do it, watch this. Okay. I'm going to create my own rectangle object. Oh, let's see what I forget. Oh, I put this in the wrong place. I'm sorry. This should have been there. Okay. I have an object. See, I'm creating an object called R. I have my object, my reference variable R, pointing at my object, which has an X, Y, H, and a Y. Notice how this time Java is actually showing me the rectangle instance because I defined it myself, whereas over here, it would not show me the rectangle instances because I'm using Java's built-in rectangle. So when I visualize this, see, it just says java.awt rectangle instance. I'm using Java's built-in rectangle. It doesn't show me what's inside of it, even though it's an X, a Y, an H, and a W. And then here, but since I wrote my own rectangle, Java Visualizer shows me exactly what's in it. Okay? And I can go ahead and put numbers in there. I can mutate the object now, x, r.x equal 5. Okay. Now, what Java Visualizer is showing me here is that this is actually kind of a method call. We're going to see that this is called the constructor. And what Java Visualizer is doing is going down here and actually creating the object. Okay, it's created the object. It went down here and created the object. Now it's back up here making the thing point. Now it's like this line of code and it's poking a number into the object. Okay, so this is where we'll start on Wednesday. We're going to start looking at what do we write to actually create our own objects. Instead of using Java's built-in rectangle, we could design our own rectangle. That's what I've done here. I've designed my own rectangle class, so I can build instances of my own rectangle. Okay. And then what's interesting is the Java visualizer works much better when I build my own objects. When I build instances of my own objects, it shows me nice pictures of them. When I build instances of built-in objects like rectangle or point, it doesn't show me nice pictures of them. I'm not sure why. I don't know why they can't draw that picture for a built-in object. But that's the way they do it. For built-in objects, they don't show you nice pictures. If you design the object yourself, you get a nice picture. So this is where we'll start on Wednesday. We want to start looking at what we do to design our own objects. And we can put anything we want in these objects. Like if I wanted to make this a 3D rectangle, I could make it a 3D rectangle. Okay. So this is where we'll pick up on Wednesday. And at that point, one last thing, we'll be starting to talk about this reading here. Okay, so what we did today was pretty much 9 and 10, these two chapters here. So it's the anatomy of a class, and I'll give you another reading for designing classes. So we're going to start talking about what's actually building our own classes. So I'm going to add another reading up here to it'll be chapter 11 in this book. If you look here, chapter 11 in this book is designing classes. So I'm going to add that reading to so read that section for Wednesday also. So I'm going to add that to the website, but that's what we're going to start doing. We're going to start designing our own classes. Okay, so I'll quit there. I've gone over a few minutes. So that's where we'll pick up. So read that chapter 11 and look these examples over, and that's where we'll pick up on Thursday. Okay, I'm sorry, on Wednesday. Okay, bye-bye.